A firm is hired to determine if certain waterways are safe for fishing. Samples are taken from 3 rivers. List elements of a sample space S using the letters F for safe to fish and N for not safe to fish. So we could have all 3 as safe. So we could have F, F, F. We could have 2 of them safe. So that would be F, F, N. It could be F, N, F. It could be F, N, F, F. So this could happen in 3 ways, 2 of them safe. It was this point, FFN, FNF, and NFF. So FFN means that the first and second are safe, third is not. FNF means first is safe, second is not, third is. And similarly here. And we should have, so in this, we've considered the case where all 3 are safe. We've considered the case where 2 of them are safe. And then we look at the case where 1 of them is safe. So 1 of them safe would be this NFN, because N is unsafe, F is safe, and then unsafe, and NF. And then we should have, we should also have, so F is occurring in the 3rd spot, 2nd spot, and we should also have a point where F occurs in the 1st spot. And it should be followed by N and N. So it's this one. And then the other possibility that is left is that all 3 are unsafe, N and N. So this is correct. Now B is not correct because B says it lists only 2 of the possibilities. The FFF is when all 3 are safe, and NNN is when all 3 are unsafe. But as we've seen, we could have all kinds of mixtures. C is incorrect because every point should be a triplet, because we're considering 3 rivers. So talking what happens to the 3 rivers, what are the possibilities to the 3 rivers? So C is out. And similarly, D only lists half of the possibilities. So in general, in order to know how many points such a sample space has, let's open a Microsoft Word and can say that in general, if an experiment is repeated n times and there are 2 possibilities, each possibilities each time, then the sample space has two power n elements. Okay, so in this case, n was 3 because we're considering 3 rivers. So here the sample space will have 2 power 3 points. So 2 power 3 is 8. And if we look at this correct answer has 8 choices. 1, 2, 3, 4, 5, 6, 7, 8. List the elements of S corresponding to event E that has at least 2 of the rivers that are safe for fishing. So safe for fishing is F. So we should look at that choice where we have at least 2 Fs. So this one is, it's not wrong, but it's incomplete because yes, both of these points have at least 2 Fs, but there are many more points that can be made that have at least 2 Fs. So this one is a bit better. That has 3 points, but still it doesn't contain everything. So for example, it doesn't contain FFF. And FFF is also an event which has at least 2 Fs. At least 2 means 2 or 3. So let's look at this one. FFF has at least 2, FFN, FNF, and NFF. So that is everything, because all the points have at least 2 Fs, and there are no more points which satisfy the condition that they will have at least 2 Fs. This D is out because FF is an invalid point. Every point should be a triplet here. So define an event that has its elements, the points FFF, NFF, FFN, NFN. Now I see a pattern here. In each of these 4 points, the middle letter is F, which means the second river is safe. F, remember, is for safe. So second river was safe. Now let's look at the other choices and see why they are not correct. The first river was not safe. So the first river not safe means every point should have N as a starter, but this one has F as a starter, so that's not correct. At least one river was safe for fishing. So now if you look at all these points, they do meet the condition that at least one river is safe for fishing. Here 3, here 2, here 2, here 1. So all of them have at least one F. But there are other points also that have at least one F. So for example, FNN, and that is not present here. So remember, whatever event you're considering, you need to list all the points that satisfy that condition. That's why C is also out. And D says the event is the same as the sample space, which obviously is not correct because the sample space has 8 elements and this event is only 4. Okay, S is the sample space and you have A, B, C, D. And you have to complete these parts. So in union, you collect all the possibilities. So the way I do it is, if I have to find A union C, I'll just first rewrite the whole of A. So 1, 3, 5, 7, 9. And then I'll start writing C, but making sure that I don't write something that I've already written here in the set. So 4 is not being written yet. 5 has been written, so I don't need to rewrite it. 6 has not been written. And 7 has not, the 7 has been written already. So that's my A union C. And an intersection, I write what's common. So A intersection B, I write whatever is common to A and B. So A is 1, 3, 5, 7, 9, B is 0, 2, 4, 6, 8. So actually nothing is common, so it's empty. This phi is a symbol for an empty set. C complement means C prime means the complement of C, which means all those elements that are in the sample space but are not in C. So let's write this down. C prime, or in general we can say A prime, denotes complement A. It consists of all points S that are not in A. So S is a usual symbol for sample space. It is usually denoted by, sample space is usually denoted by S. So A complement consists of all points that are in S but are not in A. So similarly, C complement will consist of all points that are in C that are in S but not in C. So S has 0 through 9 and C has 4, 5, 6, 7. So I start listing the elements of S, making sure that I don't list the ones that are in C. So 0, 1, 2, 3 are not in C. 4, 5, 6, 7 are, so I omit those, and then I write 8 and 9. So here I will find C complement intersection D first. So C complement I already have here. So when I do C complement and I intersect it with D, I have to write what's common in C complement and D. D has 0, 8, 9. C complement has 0, 1, 2, 3, 8, 9. So 0, 8, 9 are common to C complement and to D. So C complement intersection D is 0, 8, 9. So I just do an intermediate step. Union B, I just rewrite B, 0, 2, 4, 6, 8. Okay, and now I take the union. I can start with this set 0, 2, 4, 6, 8, and then I also write down these elements, making sure that I don't repeat anything. 0 is already there, 8 is already there, but 9 is not. So if I just add 9 to this set, it is the union of these two. So if I just add 9 here and I get rid of all the unwanted part, list the elements of the set corresponding to S intersection C whole complement. So S is the sample space. Sample space has everything under consideration. So when I intersect it with C, I will just get C. So S intersection C is just C. And then I have complement. So basically, I need the complement of C, which I already have in part C, which is 0, 1, 2, 3, 8, 9. Okay. List the elements of the set corresponding to A intersection C intersection D prime. So here there are no parentheses, so we just work from left to right. So we have A intersection C as A is this, C is this, A is 1, 3, 5, 7, 9, C is 4, 5, 6, 7. So I see that 5 is common to A and C, and so is 7. So 5 and 7 are in both C and A. So A intersection C bar is 5 and 7. And then intersection D complement. D complement, so D is 0, 8, 9. D complement is everything in S that is not in D. So S has 0, 1, 2, 0 up to 9, but I won't write the 0 because 0 is also in D. So I write 1 through 7. Okay. Because 1 through 7 are the points that are in S but not in D. So now I have to see what is common in these two, and I see 5 and 7 are common in both these two, this one and this one. So the result is 5 and 7.